going to formulate the Maxwell's distribution of molecular speeds. Let me first do some mathematics required for the derivations of that law. First of all, I try to explain the coordinate systems, and you know the coordinate systems there are two types of coordinate systems. One is Cartesian, one is Cartesian coordinates. They are expressed as x, y, z along this x-axis, y-axis and z-axis, and x-axis, y-axis, z-axis are mutually perpendicular to each other. And another is the polar coordinates, and it is expressed as r theta phi. R is the radial distance, theta is the zenith angle, and phi is the azimuthal angle. And the coordinates are required to specify the position of a point in space. Either you can express the position of this point in terms of this x, y, z, or in terms of this r, theta, phi. Let me draw the picture to show the x, y, z and r, theta, phi coordinates. And say this is the z-axis, and this one x-axis, and this one y-axis. Y, x, and z, and this is the origin. So x, y, z, these three axes are perpendicular to each other mutually. And suppose there is a point. Here is a point, and this point is represented as a P. So in order to locate the position of this point in three-dimensional space, we require either to express in Cartesian coordinates or in polar coordinates. Suppose in the Cartesian coordinates, it's called x, y, z are the coordinates. So actually, if you draw perpendicular to the on this xy plane, then it cuts this xy plane. Suppose Q. So from this point, if you draw perpendicular on this x-axis, it cuts this x-axis and this x, and x is this coordinate of this point along this x-axis. So similarly, from this point, if you draw perpendicular, perpendicular on this y-axis, then it will cut this y-axis at y, and this y is the Cartesian coordinate of this point along this y-axis. And if you draw this perpendicular to this z-axis, then it will cut also z-axis. So this one is x, this one is y, and this one is z of this point. If you know the xyz, then you can also locate this position of this point P. Suppose xy, you are given xyz, then x from this origin to this one, this is the x, and from this origin to this point it is the y, and you are drawing this perpendicular on from this point x, and from this point y it will cut at q, and from this q if you draw the perpendicular along this z axis, then if you again draw perpendicular from this z axis to this one, then it will cut here. This point is the P. So if you know this x, y, z, then you can also locate the position of this point P, and the range of x, y, z, ranges of x, y, z are, range of x, y, z are minus infinity to plus infinity. Means it will say this is origin, this is x-axis, this is the x-axis, x-axis extends plus infinity, minus infinity, plus infinity, minus infinity, and minus z also minus infinity to plus infinity. If we consider the full range of x, y, z minus infinity to plus infinity, then whole universe will be totally covered. So, if we now come to this polar coordinates, then you can draw or you can connect this OP. Connect this position from this origin, and this one is R. R is the radial distance. Radial distance R, and its range is 0 to plus infinity. It will start from 0 and extends up to the infinity, and this is the radial distance of this point P. This is polar coordinate. Here the universe have been taken as this sphere. So this radial distance makes an angle with this z axis theta, and this theta is the zenith angle. Theta is the zenith angle, and its range is 0 to pi. So it is the zenith angle. Whenever this radial distance coincides with this z axis, it is 0, and when it comes to the negative side of this z axis, then it will come to 180 degree, or say you can say the pi. And this one is, let us join OQ, and this OQ makes an angle with this x-axis, and this is phi. So phi is called the azimuthal angle. And its range is 0 to 2 pi. Whenever this OQ coincides with this x-axis, it is 0, and whenever this one rotating to again coming to this position, then it becomes this 2 pi or 360 degree. If you consider the full range, radial distance r from 0 to infinity, theta from 0 to pi, and phi azimuthal angle 0 to 2 pi, then also whole universe will be covered, and this point must remain within this universe. Say if you consider r and theta theta full range r 0 to infinity and theta 0 to pi, then these two coordinates will describe a plane on this board, on this blackboard. This plane ranges to infinity and this is the plane. And phi, whenever taking is 0 to 2 pi, then plane is rotating again by 2 pi, then the plane covers the whole universe, So this here also r theta phi, if you consider the full range, then whole universe will be covered. Now let us see what is the interconversion from the Cartesian coordinate to polar coordinate of this point. Say this one is theta, then this value is 90 minus theta. You can see better by means of a model that I have prepared. Say this is the r. This is r the radial distance. Here is the point. It is z, it is x, and it is y. So this is OQ. This from this point you draw perpendicular on this xy plane. It cuts this xy plane at a Q. So this is OQ. So if this one is the theta, zenith angle, then this one certainly will be 90 minus theta. This one will be the 90 minus theta. So this is the base, if you consider. So what will be the value of OQ? OQ equal to this is a base, this is hypotenuse, this is perpendicular, so this is 90 minus theta. So base equal to OQ. OQ equal to hypotenuse into cos 90 minus phi. So OQ equal to hypotenuse r and cos 90 minus theta. So this minus theta, this one is the 90 minus theta. This is theta. So this is equal to r sin theta. This is the value of OQ. Now let us make this conversion. Interconversion of coordinate systems. First of all, we see the jet. This is a right angle triangle. This one is the base, this is perpendicular, and this is the hypotenuse. So base is the j. OJ is the base. So z equal to hypotenuse r and cos theta. So if you know this r theta, then you can find out this value of z. Similarly, this x, this is phi. This one is also right angle triangle. This one is also right angle triangle. This is perpendicular. This is base, and this is hypotenuse. So this base equal to x equal to OQ OQ, this one, and cos theta, and or x equal to OQ equal to r sin theta, now this one is the phi, this one is the phi, this one is the phi. So this base equal to hypotenuse OQ into cos phi, and cos phi, and this y, if this is the phi, then this one is 90 minus phi, 90 minus phi, this one is 90 minus phi, this is phi, this is 90 minus phi. Again right angle triangle, this one is hypotenuse, this one is perpendicular, and this is the base. So y equal to OQ, this is hypotenuse, into cos 90 minus phi. Or you can write y equal to OQ means r sin theta, and this one is also sin phi. So we are having the three conversion. This is one, this is another x, and this is another value y. So here we can write this x equal to r, x equal to r sin theta cos phi, and y equal to r sin theta sin phi, and z equal to r cos theta. So these are the interconversions. If you have the value of r theta phi, then you can calculate this x, y, z from these relations. Now, this if you know the x, y, z from Cartesian coordinate, you can also come to the polar coordinate of this point. Cartesian coordinate, say x square plus y square plus z square equal to, from here you have this r square, sine square theta, and cos square phi, and plus r square sine square theta, sine square phi, plus r square, and this one cos square theta. So r will get common. R will get common here. Sine square theta also gets common. So sine square theta, and so coming this is sine square phi plus cos square phi, and plus here r gets common, and it is the cos square theta bracket cos. So this will be equal to r square, and sine square phi and cos square phi equal to 1. So it is sine square theta plus cos square theta. So this again sine square theta plus cos square theta again 1, and this one equal to r square. So we are having the value of r equal to r square, and r equal to x square plus y square plus z square. This is the one relation. And you see theta. Theta equal to cos theta equal to z by r. Or you can write this z by root over of x square plus y square plus z square. So theta, this is the zenith angle. Theta is the zenith angle. So zenith angle is equal to cos inverse into cos inverse of z by root over of x square plus y square plus z square bracket close. So r you can get, theta you can get from this value of x, y, z, and this phi, if you make ratio y by x equal to y by x, r cancels, sin theta cancels, sin phi by cos phi equal to tan phi, or phi equal to tan inverse y by x. So if you know this x, y, z, then r you can calculate, theta you can calculate, and this phi also you can calculate. These are the coordinates of this point P in polar systems. Let me give some small problems. Say the coordinate, the Cartesian coordinate, of a point R to root 3 and 5. Find its polar coordinates. Polar coordinates 2 root over 3, 2 root over 3 and 5. X equal to 2, y equal to root over 3, and 5 is the value of z. So you can get it from here. The solution to that problem is very simple. This r equal to root over of 2 square means 4 plus root over 3 square means 3 and 5 square means 25. So this will be equal to root over of 25, 28, 32. So r equal to 4 root over 2. So r you can calculate. This theta equal to cos inverse, and z equal to 5, and r equal to 4 root over 2, and this is equal to, this value would be equal to 28, equal to 28 degree. Then phi equal to tan inverse y by x, y equal to root over 3 and x equal to 2, and this one is equal to 41. This one equal to 41 degree. So the coordinate of this point, answer is 4 root 2 and 28 degree and 41 now I like to make a conversion of this dx dy. What will be the value of dx dy in terms of this polar coordinate? Dx dy. Dx dy infinitesimal change of x and change of y, and these two will give you this area. Say it is very easy. Say it is x-axis, it is y-axis, this one origin, and this one is dx, and this one is dy. So this will give you dx and dy whenever you are multiplying. Dx and dy whenever you are multiplying. This dx and dy will give you this area. So I will write this in some another fashion. So this is the x-axis, and this is y-axis, and this is origin, and suppose this is the value of r. This is the value of r, and this one is dr, and this value is 3. This value is 5. 5 is making an angle of this this one, say you can say this is the radial distance from this to this radial distance, and difference is dr. So this angle you can write this d phi. So this is also area, and area is the product of the two sides. One side is dr, so this you can write dr into another side is this one. This is dr, and this one is the arc in a circle. Arc in a circle. Arc. A-R-C. Arc in a circle. And it is the polar coordinates, and the whole universe have been taken as the sphere. So this is the radius of this circle, and this is the angle subtended by this arc. So this magnitude of this arc equal to this r into d phi. So r into d phi. So dx dy equal to r dr and d phi. So this relation is very important and actually required in several purposes that I will show in later on. So from this you can calculate this area of this circle. Suppose this is the circle. This is the circle, and this is x-axis, and this is y-axis, and this is the r, and angle is phi. So whenever you are considering this area, this radial distance starts from here and coming to this position, that again by rotating the radial distance, rotating by 2 pi angle. So this area of the circle you can calculate. You can find a formula of area of the circle equal to this r dr, limit 0 to r, this distance r, this is the radius of this circle, and d phi and phi limit is from 0 to 2 pi, 0 to 2 pi, 360 degree. So this one is equal to r square by 2, taking this integration and limit, and it is equal to 2 pi. So it is pi r square, pi r square. So area of this circle is pi r square. Now a little bit complicated to find this value of x, y, z. Now dx, dy and dz, product of infinitesimal small change of x, y, z. This is very important required in formulations of the Maxwell's distribution of molecular speeds and also quantum mechanics, and in different purposes. Whatever three-dimensional, we shall consider the conversion. So in this case, let us draw. This is x. This one is y. Three-dimensional x, y, z. All these three will be there, and this is the origin. Not much difficult. I have shown in little bit hard scale, and this is the theta. This is the theta, and this is r. This is dr. So dx, dy, dz will be the volume. Volume in three-dimensional space, and this value is r, and this one equal to this value, and this value is dr, and this is theta, and this value is d theta. Theta ranges from theta to theta plus d theta. So this one again arc, and this value will give you this r and d theta. Now you draw perpendicular. Now you draw a perpendicular on this xy plane, and this value, this is the OQ, and this is phi, making an angle. This one is OQ, and we know OQ equal to R sin theta. This is d phi. So this side is equal to this side, and this side again arc, whose radius is OQ, and angle subtended by this arc is DQ. So this side equal to this side, and this one is equal to OQ and d phi equal to R sin theta d. So we are having, this is volume and this is also volume. This volume is in polar coordinates. One side is dr, this is dr, this side is r d theta, and this side is r sin theta d phi. So we are having the three sides. So this will be equal to dr into r d theta into r sin theta d phi. So we can write this dx dy dz. This is equal to r square dr sin theta d theta and d phi. So from this again we can calculate the from this volume of this sphere. So whenever we shall consider let us have a formula for this for the calculations of the volume of the sphere. So volume of sphere where of radius r will be dv equal to r square dr sin theta d theta and d. So if you do this integration, then it will be integration here and this. And here is 0 to v, here 0 to r, here theta 0 to phi, and phi 0 to 2 pi. So V equal to V of volume of the sphere equal to here R cube by 3, putting this limit also we are getting this one, and this value is equal to this only 2, and this one is twice pi. So this is equal to 4 by 3 pi r cube. This is the volume. 4 by 3 pi r cube. This is the volume of this sphere. So you can have this formula to calculate the volume of a sphere from this relations. I will show several aspects of these relations, and these two relations are equally important. This is the all about of this coordinate systems. In my next lecture, I will discuss the gamma function, which is very important for the formulations of or for find the value of the standard integrals more easily. Thank you all.